So we saw on the last slide, and at least the last little section, that we had orbital diagrams. Started off low energy, high energy, and we did 1s, then 2s, 2p, 3s, 3p, 1, 1, 1 on all the s's, 3 on each p. All right, so that was the kind of the setup. Now, let's go ahead and take a look at an element and see how the electrons would fill in. So let's take a look at, why not oxygen? Oxygen, let me just give you some little room here. Oxygen has 8 electrons. Okay, so let's follow some rules. First rule, Aufbau principle. Electrons gets filled in the lowest energy orbital first. There it is. So that first one, where I guess we're talking about Aufbau, lowest energy orbital first, there it is. Then Pauli exclusion says that we can pair it up as long as there's opposite spins. So that's where the second would go. Now remember, we're putting 8 electrons into this diagram. So there's 2 of them so far. The third will go into the 2s orbital. Okay? Again, Aufbau says you go to the lowest energy until that one's filled up, and then you keep going on up. So the 2s would be where the next electron goes. The fourth would go next to it in the 2s. Now the fifth obviously goes to the 2p. Here's where Hund's rule comes in. Hund's rule says that electrons fill equal energy orbitals so that a maximum number of unpaired results. Take a look. See how these 3 orbitals are all on the same energy. If this is my energy scale, they're on the same energy. So that means that those 3 orbitals are in equal energy. Notice that I have 4 electrons put in, and I need to put in 8, right? So there would be my 5th. If I put the 6th here, 7th here, and 8th there, how many unpaired electrons do I have? I have 0 unpaired this way. Because notice, paired, 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 paired. So this is not what's going to happen. So this is incorrect here. What will happen is it follows Hund's rule. So we had our 1, 2, 3, 4. Hund's rule says equal energy orbitals so that a maximum number of unpaired results. Well, there's 5th, 6th, 7th, so they spread out across the orbitals, and then my 8th will go there. This right here is what's called the orbital diagram. Orbital diagram. It's showing, and you can use dashes as the orbitals and then the arrows as electrons. Sometimes I've seen boxes, but really it's a way of representing where the electrons are. So you can see that you have 2 in the 1s, 2 in the 2s, 4 in the 2p, and that's my 8 electrons for oxygen. Okay? Now what I want you to see here is something pretty cool. Let me go ahead and clean this up a little bit. Okay. I'm going to put my oxygen again. So there we are, low energy down here. I have my 1s, 2s, 2p, 3s, 3p. All s's have 1 dash. All p's have 3 dashes. Okay? Oxygen was 1, 2, 3, 4, 5, 6, 7, 8. We can also do what's called the electron configuration. So this is the orbital diagram. The electron configuration is a way of describing this same idea where electrons are, but not with the arrows and the dashes. The way that we do the electron configuration is we say that in the 1s we have 2 electrons, so we put 2 as a superscript. 1s we have 2. In the 2s we have 2, So we have 2 as a superscript. In the 2p, we said we had 4, right? We have 4. So 4. I got a lot of arrows going on. So 4. So notice 1s2, 2s2, 1s2, 2s2, 2p4. That tells me that I have 8 electrons. There's 2 in the 1s, 2 in the 2s, and 4 in the 2p. Okay? Now, if I do another element, let's choose sulfur. Okay? And sulfur has 16 electrons. Okay? 16 electrons. I hope that we'd all agree that the first 8 would be exactly where they are right now. Right up to where the 2p4 is. The 9th would be right next to the other singular. The 10th, the 11th, the 12th, 13th, 14th, 15th, and 16th. So there are my 16 arrows for sulfur, my 16 electrons. Orbital diagram, fully complete. I have 2 unpaired electrons right there. Okay? All the other electrons are paired, one up, one down. If I want to write the electron configuration for sulfur, 1s, I have 2. 2s, I have 2. 2p, I have 6. 3s, I have 2. 3p, I have 4. Okay? That's the electron configuration for sulfur. Okay? Now I want you to recognize something, and I'm going to be done with this little slide for a second. We'll go to the next section, but I want you to recognize something that I think is pretty cool. I hope you do as well. But basically, oxygen ends 2p4. Sulfur ends 3p4. The next set of notes show what's pretty cool about that, because there's no question about it. It's pretty cool.